Now that we have use of things like simplifying square roots and complex numbers, we can move on to higher order equations, higher than linear. And the first that we'll talk about here are quadratic equations. Quadratic equations are second-degree polynomials. That means that the highest exponent in a quadratic is a 2. If we have a highest exponent of a 2, it is a quadratic equation. They can be written in standard form like this: ax squared plus bx plus c equals 0. Sometimes you don't have the bx term, sometimes you don't have the c term, but you'll always have an x squared term in a quadratic. Down below you'll see an example of a quadratic equation. X squared minus 7x plus 10 equals 0. It is an equation because it has an equal sign. It is a quadratic because the highest exponent is a 2. In linear equations, we were hoping for one solution. In quadratic equations, we're hoping for two solutions. In general, with polynomial equations, whatever the degree is, the highest exponent, that's how many solutions you want to get for your equation. The first way that we're going to learn to solve these is using the zero product principle. I like to call it solving by factoring. All you do with the zero product principle is take your polynomial and try to factor it. It first has to be set equal to 0. So if there are things on the right side and things on the left side other than 0, you need to move everything to one side first. So in this example, we have everything to the left side equal to 0. That's good. And we'll try to factor the left side. You can go back and review that factoring lesson if you need to. This has 3 terms, so you can factor it using star method. And when you factor it, this is what it's equivalent to. X minus 5, x minus 2 equals 0. All right, the zero product principle says that if I have two things multiplied to equal 0, a times b equals 0, then I know that either a equals 0 or b equals 0. If either of those things are 0, then my whole equation equals 0 because you're multiplying by 0. All right, so what we can do is look at each of these factors here and see, can we make either of them 0? If you can make either of them 0, then you can make the whole equation 0. So for example, can you make this first parentheses 0? And if so, what would make it 0? In this case, if x equaled 5, then 5 minus 5 would be 0. For the second parentheses, you could do the same exact thing. Is there anything that can make the second parentheses 0? And again, in this case, if x was 2, that parentheses would be 0. And so this polynomial, this quadratic, has two solutions. That's exactly what we were hoping for. Remember, you can look at the degree to figure out how many solutions you want to get. We want to apply the zero product property. That means we want to solve by factoring in each of these. The first one, it has two terms. It's not a difference of squares, but it does have a GCF. We can factor out a GCF of x and have x minus 8. And then again, if we're treating this as our a and this is our b, 0 would make that first factor 0. And 8 would make the second factor 0. So 0 and 8 are the two solutions. The zero product property only works when the whole thing is equal to 0. So in the next question, the first thing we need to do is distribute and move the 12 over to the other side. This is what it looks like when you distribute. This is what it looks like when you move the 12 over to the other side. And you can notice here that everything is divisible by 2, so we can take a 2 out of everything and make that 2x squared minus 7x plus 6 equals 0. Now that it's equal to 0, we can factor it. Since it has 3 terms, we'll do star method, a times c on top, b on bottom, a on top left and top right. We're looking for things that multiply to 12 and add to negative 7. And I know that negative 3 and negative 4 will do that. This factor will not simplify, so 2x minus 3 is a factor. This factor will simplify, 1 over negative 2. So 1x minus 2 is the other factor. Sometimes it's really easy to see what would make a factor 0. So for this one, for example, 2 would make that 0. That's one of our solutions. If you can't just look at a factor and tell in your head what would make it 0, what you could do is set that factor equal to 0. So 2x minus 3 equals 0. Add the 3 to both sides. 2x equals 3. Divide by 2 on both sides. X equals 3 over 2. Again, we got two solutions. Our highest exponent when we started this problem was 2, so this is a quadratic equation. Same thing here, highest exponent was a 2, and we got two solutions. Another way you could solve, if you have this special type of polynomial where you don't have an x term, right? So we're talking about a polynomial in standard form, ax squared plus bx plus c equals 0. If there's no regular x term, if there's just an x squared and a numeric term, we can use the square root property. And the way you do that is you get the x squared by itself equal to a number. Once you can do that, you can take the square root on both sides. And when you take the square root on both sides, x equals plus or minus whatever the square root of that number is. Remember, you want to end up with two solutions, and the plus or minus gives you those two solutions. It's positive of that number and negative of that number. Starting off with our simplest example, x squared equals 64. The x squared is already by itself, so we can start automatically by taking the square root of both sides. There's no x term, so we know we can apply the square root principle. So x equals plus or minus. It's key that you remember to do the plus or minus if you take the square root on both sides of an equation. The square root of 64 is just 8. Remember we said we wanted two solutions? The two solutions are built in there. This is really saying x equals 8 or negative 8, right? Plus or minus 8 is just positive or negative 8. On the next one, we want it to be just x squared equals a number, or y squared equals a number, whatever the variable. So we need to move the 36 over first. 2y squared equals negative 36. We still don't have just y squared equal to a number, so we can divide by 2 on both sides, and we'll get y squared equals negative 18. Again, once you get your variable squared on one side, you can use the square root property. And you'll have y equals plus or minus the square root of negative 18. And in that complex numbers review, we talked about how we could break down that 18. The 18 can be broken down into 9 and 2. The 9 can be broken down into 3 and 3. And since there's a negative inside that square root, our answer will actually be plus or minus I. That'd be actually 3i, right? The 3's have buddies, they can come outside. 3i square root 2 does not have a buddy, he has to stay inside. Those are our two answers. We have one more, and this one's a little bit special, where we have a group squared. That's still perfectly fine. If we have a group squared equals just a number, we can square root that whole group. And when we do it, we have anything squared. If you take the square root of it, you just get that thing out, and a plus or minus on the other side. Breaking this down with a factor tree, w plus 3 equals plus or minus 2 square root of 2. We need to subtract the 3. And notice that these things are not like terms here. 3 and 2 square root of 2 are not like terms. So w equals negative 3 plus or minus 2 square root of 2. Again, we needed two answers, and we have two answers, the positive and the negative version of that. That's 3 plus 2 square root of 2 and 3 minus 2 square root of 2. Or I'm sorry, it's negative 3 plus 2 square root of 2 and negative 3 minus 2 square root of 2. Another way we could solve these is by completing the square. This completing the square, if you don't get it this time, it's fine. We're going to see it again when we get to circles. So with completing the square, what we want to do is create a perfect square trinomial so that we're sort of manufacturing the polynomial so that when you do star method, you get the same number on the left and right. And then instead of writing it out twice, x plus 5 and x plus 5, you can write it as x plus 5 squared. That's what it's showing here. So whenever we get to a problem, what we're going to do is we're going to manufacture a polynomial that's in that form so that it will come out to be a perfect square. Manufacture a polynomial in that form so it will come up to be a perfect square whenever we do star method. There's a way to do this. There's a specific way to do this. So what we're going to do is we're going to look for this number right here. The way you get that number, as long as this is a 1, if it's not a 1, you have to make that a 1, okay? And the way that you do that is by dividing whatever it is. So if that was 2x squared, I would divide every single thing by 2. In this case, it's a 1, so we're already at that step. If that's a 1, what you're going to do is take this term right here, the coefficient. You're going to divide it by 2 and then square it. So 18 divided by 2, that's 9. Square that is 81. So what we need here is an 81. What that makes is something that when I do the star method, it turns out to be a perfect square. Same thing on the next one. As long as that's a 1, which it is, we could take this number here, half it, so negative 13 over 2, and square it. That would be 169 over 4. I'm just squaring the top and squaring the bottom. 169 over 4. Creating that perfect square polynomial, again, allows me to do star method and get a perfect square. Same thing here. See that a term is a 1. We can look at the b term, 4 over 7. Divide it by 2 is the same thing as multiplying it by a half, so that'd be 4 over 14. Square it. That's the same thing as 2 over 7 squared. I'm just going to simplify the fraction first because it's easier to think about. 4 over 49. So then that number can go here, 4 over 49. Again, creating that gives us a perfect square binomial. All right. Take a second, pause your video, and see if you can figure out what this number should be to make a perfect square. And then we can factor it. I'm going to show you the key to the factoring part as well. For the first one, we'd say 12 over 2 is 6. 6 squared is 36. So this number right here needs to be 36. Now we're only going to do star method once because we're going to try and find out the key here. I'm sorry, I have the wrong number there. That's a 36. 12, 1 and a 1. Here, 6 times 6 is 36, and 6 plus 6 is 12. So that would be x plus 6 and x plus 6, or x plus 6 squared. All right, if you look around the page to see if you can find another 6, notice that it's that middle thing. It's whenever you divide it by 2, it's that thing. Let's see if that stands here. So x plus 5, we'd say 5 over 2. 5 divided by 2 is just 5 over 2. Square that would be 25 over 4. So 25 over 4 is the number that needs to go there. And then when you factor it, you're always going to take the number just before you square it. It's x plus 5 over 2 squared. The sign does matter. That sign is always going to match the sign that's in there. All right, here we've got a 2 over 3, negative 2 over 3 in fact. Negative 2 over 3, half that, so divide it by 2, so multiply it by 1/2, would be negative 2 over 6, same thing as negative 1 over 3. Now I'm ready to square it, and I get 1 over 9. So 1 over 9 is the number that needs to go there. This last number, key, is always going to be positive, okay? That number is always going to be positive. This number in the middle is always going to match the sign you had there. This number here is going to match the sign you had there. So here I had a negative. I know I'm going to have x minus, and you're always taking the number just before you squared it, 1/3. Notice that that was a negative 1/3, which gave me the minus 1/3 here. All right, let's try to apply that to solve some quadratic equations now. So what we can do is, again, we get the x's to one side. We're going to get the numbers to the other side. So x squared plus 10x equals 3. Then we're going to do our completing the square step. So half of that is 5, squared is 25. X squared plus 10x plus 25. To maintain a balanced equation, I have to add 25 to both sides. On the left side, we can do our star method, or remember that this is x plus 5 squared. On the right side, 3 plus 25 is 28. Now that we have something that looks like a perfect square, we could square root both sides just like we were doing before and have x plus 5 equals plus or minus square root of 28. If you take this and break it down into a factor tree, 2 and 14, 2 and 7, 2's get to go outside, the 7 has to stay inside, so plus or minus 2 square root of 7. Then subtract the 5 over. Let's try another one like this. So what we want is all our variables to one side, the numbers on the other. X squared minus 8x equals 2. I added the 2 to the right. I subtracted the 8x to the left. The 8x and the x squared can't combine because they're not like terms. So now to make a perfect square binomial, what I can do is divide that by 2, negative 8 divided by 2, negative 4, then square it to make 16. So I need to add 16 to both sides. On the left side, I can do star method here, and I know I'm going to end up with x minus 4 and x minus 4. 2 plus 16 is 18. I can apply that square root principle because I have something squared equals a number. Then I can simplify this, 2 and 9, 3 and 3. So that's plus or minus 3 square root of 2. Then I can add the 4 over. And there's my final answer. Remember, with all these, you do want 2 answers. For any quadratic, you want 2 answers, and this does count as 2. This is the same as negative 4 plus 3 square root of 2 and negative 4 minus 3 square root of 2. All right, if you have one, note that a is not equal to 1. On every single one so far, this coefficient has been a 1. If you have something where that's not a 1, you're still going to follow the same steps, but you have to get that to equal a 1. And the way that you do that is by dividing by whatever that coefficient is. So we can divide every single thing by negative 2. So that'd be x squared plus 3 over 2x plus 5 over 2 equals 0. Again, we want our x's to one side and our numbers to the other, so x squared plus 3 over 2x equals 5 over 2. And now's the point where we're trying to make our perfect square, so 3 over 2 times a half. That'd be 3 over 4. Squared would be 9 over 16. So 9 over 16 is what you want to add to both sides. I know that on the left side, right before I squared that, is what I'm going to have in that parentheses. 5 halves plus 9 over 16. I'm trying to do this math in my head. Should be something like 49 over 16. You can take the square root on both sides. You end up with x plus 3/4 equals plus or minus 7 over 4. That turned out nicely. And if you have ones that you can combine, on all the rest, we had some square root stuff, so we could not combine our terms there. Here, we don't have any square roots, so we can actually combine our terms. We can actually just say negative 3/4 plus 7/4 would be, in our calculator, a positive 1. Negative 3/4 minus 7/4 would be in our calculator negative 10 over 4, which is the same thing as negative 5 over 2. We got two much nicer answers there. If you do end up with a nicer answer, then you know that you could have just solved it by factoring. So I could have taken this thing right here, done star method, and got the answer much more quickly. If you get a nice answer from this method or from the next method, then you should have just done star method. The good thing is that this one is more foolproof. You can do this with any quadratic equation and get the right answer, where star method or factoring only works when it works, right? This method will always work. This method will also always work. So this is the quadratic formula. It will work anytime you have a quadratic formula. The quadratic formula, your quadratic equation does have to be equal to 0 before you start to solve here. So you have to have the whole thing equal to 0. If it's equal to 0, then you can use this quadratic formula. Take a minute and write down that formula, and you will want to memorize that formula before you get to your test. All right, let's apply the formula. Remember that we have to have ax squared plus bx plus c equals 0 before you can apply it. So to get that, we need to distribute x squared minus 6x equals 3. We need to get the 3 over. X squared minus 6x minus 3 equals 0. My workflow, every time I get a new problem, I get it equal to 0, and then I want to try to factor first because it's so much faster if you can. So if I could factor this with star method, I would, absolutely. In this case, 3, 6, 1, 1, there's just no numbers that will fit here that will multiply to 3 and also add to 6. So I cannot do star method on this one. I have to actually go with the quadratic formula. Now that you've memorized your formula, we know x equals, if this is a, b, c. A is 1, right? B is negative 6, c is negative 3. X equals negative b. So that's negative negative 6, which is a positive 6, plus or minus the square root, b squared minus 4ac all over 2a. And now I'm just going to try and simplify, 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 simplify. We're always going to start inside the square root. That's something called the discriminant. We're going to see it in just a minute. If you simplify that, 36 plus 12 is 48. 6 plus or minus square root of 48 over 2. The next thing you need to do oh, I did math wrong here. I'm sorry. I'm glad I checked that in my calculator. That's not 48. If you type in 6 squared minus 4 times negative 3, that would be plus 12. Oh, it is 48. I'm sorry. I'm undoing and redoing. 48. All right, the next thing we need to do is take this 48 and try and simplify it. So 48, I can break it down into 3 and 16. 16 is 4 and 4. 4 is 2 and 2. 4 is 2 and 2. You got buddies, buddies, and he has to stay inside. So there'd be 6 plus or minus 4 square root of 3 over 2. A lot of times people want to stop right here, and if you type that into MyLab, it's going to tell you that you need to simplify your answer. What you need to do is look at all the things that are not in the square root. Don't look at the thing in the square root. Can you divide all the other 3 things by the same number? And they're all even, so we can divide them all by 2. And actually on the bottom we get over 1. Anything over 1 is just itself. Like if I had 5 over 1, that's the same thing as just 5, right? So since the bottom here goes to 1, we can just leave the bottom off. So the 2 divided by 2 would be 1, and we could just leave that off our answer. That's our final answer. This question we could have also done by completing the square if we wanted to. All right. We can look at this discriminant now, and it will tell us how many of what type of answer we get. So I'm talking about just the thing under the square root, the b squared minus 4ac, the part that I've highlighted there. So for any problem, if this part is negative, if b squared minus 4ac is negative, if it's less than 0, you're going to have two non-real solutions. That means complex. That means they're going to be something like a plus bi. If that discriminant turns out to be 0, you're going to have one real solution. And if this turns out bigger than 0, that means it's positive. So this means it's negative. This means it's 0. This means it's positive. If it turns out positive, it's going to have two real solutions. Typically, examples of these are not going to ask you to actually solve the equation, okay? It's going to say use the discriminant to determine the number and type of solutions. So for this one right here, we don't actually have to apply the whole quadratic formula. We can just say b squared minus 4ac. It says use the discriminant. Don't overwork yourself. Use the discriminant to determine how many and what type of solutions. b squared minus 4ac here. Again, this is a, b, c. Keeping the signs as well. Negative 3 squared minus 4 times 5 times 1. That would be 9 minus 20 would be negative 11. That means we have two complex solutions. I think on Alex or my lab, they might call them non-real. It does have to be equal to 0 before you start to do this. So on these next two examples, you want to get it equal to 0 first. So on this one, I'm going to say that's 2x squared plus 6x minus 3 equals 0. Then I can do b squared minus 4ac. That would be 6 squared minus 4 times 2 times negative 3. 36 plus 24 would be 50. And we don't even have to do any more work. All we have to do is look at the chart and say that's a positive number, which means we're going to have two real solutions. Two real solutions. That's the same way I got this right here, is because the 11 turned out to be a negative number. And in our negative part of the chart, it says we're going to have complex, two non-real solutions, or two complex solutions. Pause and try C. You do want to get it equal to 0 first. Sub in our numbers. 4 times 4 times 9 is 144. 144 minus 144 is 0. And if you look back at your chart, that means it has one real solution. Again, this is not asking us to find the solutions. It's just asking us how many solutions does it have, what kind of solutions are there. If it ever asks you to use the discriminant, you're not going to have a real number answer. You're just going to say, use the discriminant to find out how many solutions does it have. All right, we can also do literal equations with quadratics. So let's try and solve this literal equation. We're trying to solve it for r. That means we're trying to get r by itself. If we're trying to get r by itself, I always like to clear all the fractions first. So multiply by 3, multiply by 3. I'm only doing it twice because I only have two terms. You want to get r by itself, so you can divide by pi and h. Divide by pi and h on both sides. Remember, we're trying to keep this balanced. 3v over pi h equals r squared. Remember, if you have your variable squared on one side, you can take the square root on both sides to clear it, and you will always get a plus or minus. And that's what r is equal to. Whenever you're trying to solve for a variable, you know you're done when you have that variable on a side by itself. Here's another for you to try. This one we're trying to solve for t. T is in two different spots here. Whoopsies, t is in two different spots here. And so we're going to have to actually use the quadratic equation. if you sub in a quadratic equation using that as a, b, and that should actually be negative z, right? mt squared plus nt minus z equals 0. So get the whole thing equal to 0. Sub your a, b, and c into the quadratic equation. That should be a negative z here. With the negative z there, that's going to make that plus 4mz. And that's actually all you can do there. You can't go any further. There's no way to combine any like terms. There's no numbers that we can sub in to find a better answer. That just is the answer that we have. All right, that's solving equations with quadratics. Again, my workflow would always be to try to solve by factoring first. If you could solve by factoring, it's going to save you some time. If you cannot solve by factoring, you could do completing the square or you could do quadratic equation. Either of those will get you the answer every time. They just might not be the fastest way to do it. All right, see you in the next lesson where we're going to try and apply some of these quadratics.